Today we're going to work on this White-Rodgers integrated furnace control board. We had already replaced the circuit board, and we're going to just take a look at it and see what we can do to fix it. I'm looking at the paperwork and see if there's anything included in here that I might be able to use for testing purposes, to see what I will be doing to it to fix it, actually fixes it or not. Well, there's the wire diagram right here. So we can take and connect some stuff to it. Cool heat, part, line, transformer, EAC, I'm not sure, electronic air cleaner, okay. So we can go through here and if these are outputs, we can be able to measure those for the voltmeter easily. So, igniter hot side, inducer, .24 volt AC transformer, low side, common side. These are your thermostat wires. So it doesn't look like, other than your line would be your 120 volts in. I don't know if this has a transformer on here or not. A very basic looking module. There's just spade connectors right there. A 2-pin connector here and this connector there. And your terminal strip, and you have an on-off switch. Which switch 2 is on and switch 1 is off. And then you have your bare circuit board on the back side, which has been conformal coated. So if you do notice here, there's a big black soot mark. They burned the trace up. I'm guessing to a relay. I can't really tell yet. We're going to attempt to take it out. They have these little these little braces here. So I'm going to try to pry this a little bit here. See if I can get this open. Push it open. Get the circuit board out. Not sure exactly how I'm going to be doing this. You'll see with me. If you follow my video, just make sure you're not damaging any of the surface mount components. Okay, I pushed that way and I got that over. We're going to do the same for the sides. I can get this side here. Now this side, I'm going to keep pushing up down here with the terminal strip. And do this one as well. Same way. I should be able to just convince this to come out. Okay. Looks like I got a EEPROM chip, a little microcontroller. 1, 2, 3, 4, 5 relays. It's like one diode and a series of resistors. I'm gonna let this be in the view so you can see if some of your resistors are burned up. You'll be able to look at that. So we will be trying to plug this stuff in, and I'm going to see if I can actually manually trigger some of this stuff, except for like the 24 volt stuff. We're gonna have to get a transformer or something, because they did not have capabilities here to transfer 120 volts AC to this. So I would like to take the conformer coating off and see what I can do with it. I'm going to show you guys some stuff about this. You can learn some stuff about what I call, or what everybody calls, it's basically cold solder joints. And you can see firsthand what the cold solder joints looks like. And by fixing the cold solder joint, we just add solder to it. We heat up the solder joint and add more solder to it. It's a very simple deal. As far as this here, it is a relay. And it does look like it just got burnt. The trace is burnt itself. I'm guessing that that relay is toast. It got stuck on, and it's just too much current, and it went up and burnt the trace. We can take that relay apart. Part number for the relay is JTN1AE-PA-F-DC24 volts. Let's put that one right here. So I can look that up and see what this function really is. I can see this side here is the coil side. You got a transistor turning it on, switching it to ground probably. And then the bigger end here would be your contact side. So none of this here is part of the relay. There's just these connectors here. So, oops. It's like this point here is the contact for this. I don't see any other spot that it would be. It's really interesting. I'm gonna open this relay up. Might be able to just remove it from the circuit board and see if it's open underneath. Let's do that. And I'm gonna get some rubbing alcohol. I'm gonna remove the conformal coating, and then I'll show you some cold solder joints that's on this circuit board. So this is just pertaining to what I'm going to be able to fix here. You might be able to look at some of your circuitry in here on your board and see that you can quickly and easily fix your circuits. And then I'm going to try to figure out how I can test this with actually not hooking it back up to a heater to a furnace. So, see what happens. Alright, so we're gonna attempt to remove this relay and see what happens. Let's just solder and iron get warmed up. Kind of zoom in so you can see what I'm doing. These are the first two solder points, is this one and this one. Whatever that is. So we're gonna heat up this part right here, this lead. Right there where it says TP1 is test point 1, and this resistor here we're gonna heat up, and I'm pulling backward onto this relay and creating a force. And then the relay is dropped. Just like that. Up here, this is the contact side. Making a mess. That's alright, that's what my intentions were. So you can see that this moves back and forth like this. So when the relay energizes, it will pull this down, and you're going to make and break connections on this side. There. Now we can clearly see. Let me bring a light over here. I'm going to zoom in a little bit. Let the camera stop shaking for a second. And you can clearly see how burnt that one contact was. That's amazing. Now that was on this side here. This side here was really arcing bad. The other side wasn't too bad. So I think that failure was probably just bad contact. So if we get a new relay, should be able to fix this up pretty good. And getting a new relay should fix this circuit board's problem with an additional to take in, making that trace available again. I would have to make sure that none of the components around the area got affected. I doubt it did. But on to the next thing. This guy right here. Let's say we're going to look at the wire diagram. I'm going to say that you're having problems with, well, they don't really show you, do they? This here is all symbols. So MV is gas valve, Burst gas valve. Solenoids are connected in parallel. Your TR is the 24 volt transformer. Common side. TH would be transformer. Okay. So basically, everything that's in this circuit, this little blotch there, if you're having problems in that area with your heater, chances are, and then you swap this board out and it fixes it again. If you're an HVAC guy, I'm telling you what you can do to fix this. So, I mean, I think this board was like 60 to 100 bucks. I'm not sure exactly what the price was. I can look it up. But I'm going to show you what you can do to fix this, and I'll show you in just a second. So all of these are called solder joints, right? And solder joints, they have what's called cold solder joints. And if you can identify them, it's going to help you. And I'm going to point out some cold solder joints. I'm going to put my phone down so it's not shaking so much. I record everything with my phone. I'm going to point out some cold solder joints so you'll be able to fix your own circuit board here. If you can see this line, there's a circle around this solder joint here. That's what's called a cold solder joint. So this one here has it. This one here has it. It's pretty obvious. This one back here has it. I have to get it in a different angle. If we look at it in different sides, you can definitely see this one has it. This one's got the start of it. This one has it here. I'm showing my light a little bit better. So we already know this one's got it. This one's got it. This one has it. This one has it. To a different angle, you can see that this one has it. But pretty much, they all have cold solder joints on this one connector here. This is a common problem with that style connector. And probably, if the circuit board was made after the year of 2005, which I'm not sure if it was or wasn't. I don't know if this is lead-free solder. If it is, that's going to be the reason why. So let's look at some other solder joints. These look good. This, not so much. In the electronic world, that is probably the second highest failure in electronic circuitry, next to bad filter capacitors. You know, we're talking about, you know, more so for TVs and radios and stuff like that, not like somebody else's manufactured board. Typically, you would think you would have somebody that has quality control and look at this, but obviously they don't. So I'm just pointing out the faults. Okay, so pretty much everything else looks alright. So if you can identify yourself, you can see that all of these solder joints here have bad solder joints, cold solder joints, then you'll know for a fact that you'll be able to fix these devices. Now if you're watching this and you have a circuit board from a different heater or whatever, and you want to send it in for me to fix, just let me know. Send me an email. I'll put it at the end of this video. And if you can help me out by showing that it worked after you installed it, that's going to be awesome. Well, we can work out a deal where you just send it in, I fix it for you. You send me a video, show that what I'm doing here is actually going to fix your device. It's going to help me out in the long run. So, if you do that, thanks. I really appreciate it. So now to fix this, it's really simple. Let my soldering iron heat up. And then we're going to reheat all these solder joints. They're pretty simple. You can buy a cheapo $5 soldering iron from Walmart, and it's going to work the same. So what we're going to do, you're going to take and clean your tip. You're not going to have a crappy tip like I do. And you're going to heat this area up. I see that it's being pulled away. I find that interesting. So that tells me that they didn't have a good flow there. That's interesting. Let's try it on another one. I may have to take all the solder off and scratch these. Scratch them up a little bit. It used to be something back in the 60s, 70s, and 80s. Circuit boards they used. The rosin is inside your flux, inside the solder, cause issues like this. As you can see that this is kind of sitting on top, it's just like a bubble. And this one isn't, because I heated it up a little bit better. I'm going to do that for this one here too. Now I'm going to retouch this one up here, I know with the blob. You can see it with all the stuff. Well, they no longer have cold solder joints, so that's a good thing. I would just suggest taking and scraping all the conformal coating off of this before getting to it. I gotta make sure that this is actually connected to this. It may still have conformal coating underneath there. I think what I did was just heat up the thing, solder point, and this conformal coating got underneath there, and it was not allowing me to get contact underneath the solder joint here. So I think that was part of the problem. I'm not sure what kind of conformal coating they used, but it's a pretty stout stuff. But there you have it. That's if you have a problem in this circuit, you know now that you're going to have to reheat this area and trouble that you're going to have going through this. I'm going to take and buy a relay for that. And then I'll take and fix the trace for here. And I'm not really sure exactly how I'm going to be able to test it. I don't think I will be able to test it. They already replaced the circuit board. So it's not like I have anything on hand right now that I can go through and check if this relay does this, this, and that. I might be able to simulate it, but I would have to figure out circuitry and how it works and all that. cut, so that's your best bet. If you have problems with the circuitry in this area, you're going to have cold solder joints. Removing these relays here is really simple. Probably get them for $5 each, cheaper than that, really. Kind of looking at to see if I can find a date when these things were manufactured. So they bought a new one, and this is a cross-reference to a bunch of these other stuff. So this could be a substantial amount of circuitry that this one thing here could fix. It appears to be the same circuit here. They took the fuse. So that's the exact same, except there's just a 2-pin and they have a 4-pin there. White-Rodgers Universal 50A55-E43. So it's the same exact model basically, except they have a 4-pin connector and they have 2 extra dip switches right here. So this particular model (50A55-288). This particular universal one will fix. I mean, I imagine all of these 50A 50 dash blah blah blah. It's going to look exactly like this with some software change right there, and that would be the end of it. That's the extent of what it will be able to do differently from the other. So hopefully this was able to guide you into fixing your own. I will look and see what the cost of this guy is. Could be just as simple as resoldering that and changing the $5 relay. Thanks for watching, guys. Let me know if this helped you out. I'll see you next time.